All righty now, we were just finishing, oh, we were just starting. Okay. Thank you. Just starting the hyperbolic paraboloid. So as I said, this one is a bear to draw. So I got some help from your book. Okay, so number 6 is the hyperboloid. And the hyperboloid is x squared. Uh-oh, I'm in red. I'm like, x squared over a squared minus y squared over b squared is equal to z. Okay. Now, the reason why this one is so tough is because you're going to see 3 different things and you have to put them all together. Okay, so again, let's start with the z equals 0. Obviously, z is equal to 0 gives us x squared over a squared is equal to y squared over b squared. And that just says that y is equal to plus or minus b over ax. So we get lines. Okay, so that's when x is equal to 0. Sorry, z is equal to 0. But suppose z is not equal to 0. Okay, well, if z is equal to some k squared, so it's a positive number, then you get x squared over a squared minus y squared over b squared is equal to k squared, otherwise known as x squared over ak squared minus y squared over bk squared is equal to 1. And this is a hyperbola. That opens in the x direction. Okay. And if z is equal to minus k squared, so it is less than 0, then you get x squared over a squared minus y squared over b squared is equal to negative k squared, or y squared over bk squared minus x squared over ak squared is equal to 1. And so now we're going to get hyperbolas in the y direction. Okay. All righty. Now what happens if y is equal to 0? So now I get x squared over a squared is equal to z. So I get parabolas. that look like this. And if x is greater than 0, if x is equal to 0, I get minus y squared over b squared is equal to z. And again, I will get parabolas. But these are like this. Okay. Ooh, let's put this monster together. This is hard. I wish I had some other options. That's it. There are no other options. Okay, since there are no other options, I'm stuck. Okay, positive x-axis, positive y-axis, positive z-axis. All right, so in the xz plane, in the xy plane, that's when z is equal to 0. We get lines. I don't even see these lines. All right. When x equals 0, let's do that one. When x equals 0, I know I'm going to get I'm going to get something that looks like this. And when y equals 0, I get something that looks like okay, I can't draw this because this axis doesn't work for me. I'm going to have to draw my own because I need it to be tilted, and this won't draw one tilted for me. So I'm going to draw my own. So here's Z, and here is X. And here is Y. Now I can work with that. Okay. So in the ZY plane, I have parabolas going down like this. And in the ZX plane, I have parabolas going up like this. And then in these other planes, I have hyperbolas that look like this. So now, if you can picture this thing, what you are seeing is a saddle. you should be seeing, and you got to look real hard, but you should be able to see the man sitting on the saddle. Now, I told you it's hard to draw. So here is my picture of this thing. So you have, this is right here. This is the parabola in the ZX plane. Looks like that. The parabola upside down goes here and down on the other side. And then here's the hyperbolus. Here's one, and the other one's behind there. Okay, so that's the hyperbolic paraboloid. Okay. The parabolic cylinder is EZ. So the parabolic cylinder looks exactly like the parabola from before. So if you remember the parabola x squared over 4p equals y, where p was where the distance to the focus. Okay, so notice there's no mention of z. So that means this happens for all z. So if I draw a picture and I have a parabola in the XY plane, so I have a parabola that looks like this in this plane, then it means it actually is doing this for every value. So it's just that line shouldn't come over there. So it's just a sheet. Okay, so it's a parabolic sheet. So it's a cylinder in a shape of a parabola, but it is a sheet. So let me see, did I grab a picture of that? No. But it is a sheet. So it's kind of like a bent piece of metal, okay, in the shape of a parabola that goes all the way up to the sky and all the way down to the sky, down to the ground. The next one is the elliptic cylinder. It's the same thing. It is x squared over a squared plus y squared over b squared is equal to 1. Okay, so again, no mention of z. So it happens for all z. Okay, so therefore, if I take and I draw my axis, and I have a cylinder in the XY plane, I'm sorry, I have an ellipse in the XY plane, I have this same ellipse is like that. So it is a cylinder. So it's, you can see the shading. Of the cylinder. Okay. And then the hyperbolic cylinder, wait a minute, that is number 9. So for the hyperbolic cylinder, it's the same as x squared over a squared minus y squared over b squared is equal to 1. And again, no mention of z, so it happens for every z. Okay. So therefore, this one so I may have a hyperbola that looks like this. But this is actually a sheet. And then this side has the other side of the sheet. Okay, I think that's the best one I drew. Okay, so now here's where life gets scary. They're not always facing in that direction. Okay, so for example, say I have I have x minus y squared minus 6z squared, it equals 0. So that says x is equal to y squared plus z squared. Well, that kind of looks like this one back here. Nope, it looks like that's a paraboloid. It's a paraboloid as soon as I get to it. Did I skip it? Oh my gosh, I think I might have skipped one. The elliptic paraboloid should have been number 5. How did number 5 turn out to be a cone? Oh, I skipped number 5. Oh. All right, so let's skip this for a moment. Like I said, we ain't never gonna get done. Yeah, let's do number 5. Okay, so number 5 is elliptic paraboloid. All right, so an elliptic paraboloid is a picture here of it. Where'd it go? There it is. So it is an ellipse in 2 directions and a parabola in 1. So you can see that because it looks like x squared over a squared plus y squared over b squared is equal to z. So in the xy planes, it is an ellipse. I'm sorry, in the xz plane, it is an ellipse. I thought I did this one. And no, I didn't. And in the YZ plane is also an ellipse, a parabola. But if Z is any number equal to K squared, then I get an ellipse, X squared over A squared plus Y squared over Z squared over B squared is equal to some number K squared. These are ellipses. So this thing looks like that. This thing has parabola in 1 direction. I feel like I did this though. I don't know why I feel like I did this. A parabola in another direction. And then ellipses in this direction. So that is that. Okay, so now I can go on to say, for example, x minus x minus y squared x minus y squared minus 6z squared is equal to 0. So this now says x is equal to y squared over 1 squared plus z squared over 1 over 6 squared. No, 1 over the square root of 6 squared. Okay, so this is the same thing. It's still an elliptic paraboloid. No, it's still, no, yeah, it's still an elliptic paraboloid. But this one is on its side. So this one looks like this. And then this one looks like that. And then it has, so it faces the X direction. Okay, so take a look at the section, please. It's the only way you're going to get a better idea. They do great pictures. I'm not an artist. I do the best I can at drawing these. I know what they are. I know what they look like. But I have a terrific time trying to draw them. Okay.
Okay.